Okay, so in a KEQ, what do we do with our coefficient? We use it as the exponent. Yes? So if the coefficient of A is A, little a, then we raise concentration of A to the exponent, the coefficient. So these are the coefficients. Yes? So for B, we have a coefficient of B. Yes? So just bear in mind that it's different. Okay, that's all. Right? For rate law, you can't. For KEQ, you do. Note that the coefficients become the powers in the equilibrium expression. That's what this thing is called. This is called the equilibrium expression. This bit here is the equilibrium expression when you actually write the products over the reactants. KEQ is known as the equilibrium constant. Now, the equilibrium constant includes only substances that can vary in concentration. Please tell your partner things that do not vary in concentration. What types of substances do not vary in concentration? What classifications of substances do we not include? Yes. Solids and liquids. Okay, so we do include gases. So we can say gas. Yes. Because we can change the pressure of a gas. We can make the container bigger or smaller or add more particles to the container. We can change the concentration of a gas. How about aqueous? Can we change its concentration? Yes. Solids? No. Pure liquids? No. Now, this last one shows up so infrequently that I hate telling you about it because people get all wound up about it. Oh, what if it's a mixture of two liquids? You're never going to get that. Do we understand? Yes. I'm telling you about it because it does exist, but it is a super rare thing unless you're dealing with organic chemicals, and you will not be doing that this year. Okay? So, if you have a mixture of liquids, right? So if you have A, which is a liquid, plus B, which is gas in equilibrium with C, which is a liquid. If you have two liquids or more, and they are miscible, what does miscible mean? Mixable. They can change each other's concentrations, right? So if you have alcohol and water, yes, you'll see like on a bottle of wine, usually it's like 14% alcohol. That's about how 12 to 14, somewhere in there, that's as far as you can get without doing a distillation process. If you get, distilled liquor, you can get up to like 40%, which is pretty like, whoa. Okay, like a beer or something is usually 5%. So you can change the concentration of alcohol in water, which would mean that the water would be, either 95% or 85% or 60%. Yes? Okay. How do you know if two liquids are miscible? What rule do you use? Ooh, I heard it. Hydrogen bonding. Like dissolves like. So what are we talking about when we're talking about like and unlike? Partially. We're talking about things which are polar and non-polar. So polar dissolves polar. We talked about this earlier, remember? Okay. And non-polar dissolves non-polar. So alcohol, polar. Water, polar. They'll mix with each other. How about oil? Oil is non-polar, water is polar, they will not mix. Okay? Okay, so that's like dissolves like. So if you have two miscible liquids, now that we've spent all that time on that, how often does that come up? Never, okay? Like so rarely that you might as well say never, okay? But let's take a look at these examples and let us write the, first of all, let's go through and highlight all the species that we should include. Can you go do that? Highlight all the species that you should include and then write the KEQ expression. What do we do if there's no products to put up top? Put a 1. Very good. Is CH3OH polar? How can you tell? Because of the OH, yes? It's not, it's asymmetrical. Okay, it's asymmetrical and it has something which is very electronegative. Very electronegative. Therefore, it is polar. How about polar or non-polar? Polar, because it is bent, which means it and we have lone pairs here, yes? Lone pairs. So is it symmetrical or asymmetrical? Asymmetrical. Remember, it has to be symmetrical in 360-degree kind of thing, right? You can't just be bilaterally symmetrical because you've got one end, you've got the top end, which is very negative compared with the bottom end, which is more positive. Okay, so we would have a slightly negative end and a slightly positive end. So it's asymmetrical, so it is polar. And of course, we know that water is polar because it is asymmetrical, and we've got that lovely juicy old electronegative oxygen. Okay. All right. So what would we write for our KEQ here? Because we got polar, polar, polar. Would we include all those liquids? Yes, we would, because they are miscible. And that's probably the last time you will ever see such an example. Yes, because miscible liquids in an equilibrium in grade 12, in AP Chem, super rare. Is good? Okay. I'm going to let you do these exercises at home. Let's move into calculations. You guys are going to love this because it's just like write the expression, throw in the numbers, solve. It's like, oh, it's like grade 9, right? Other than the fact that you have to write a KEQ expression. So we have on page 93, we have this equilibrium here. And we are told that at a certain concentration, the equilibrium concentrations are, and we have HCl, F2, Cl2, and HF. So those are the concentrations at equilibrium. From this data, calculate the KEQ. What do you imagine that you have to do first? You have to write the KEQ expression. If you leave that out and you just go chucking numbers in without writing the KEQ expression, you will lose, on my quizzes, a half a mark or a full mark, depending on what the quiz is. So try it. I bet you can do it. In this case, the molarity cancels. KEQ, although you can write a unit for it, nobody ever does because it's pretty much meaningless, okay? Because it's going to be different under every circumstance, okay? So we can assume that KEQ is assumed to have no units. No unit. And later on, when you solve for a particular concentration, you'll just be like, I've solved for a concentration, therefore my unit is molar. Okay? So, because KEQ is assumed to have no unit, you do not need to write the units in the calculation. This is different from everything you have ever done, yes? You do not need units in the KEQ calculation. Yes, Rigel. So you would just have products and then you would have nothing on the bottom. You would just have a 1. No. It is assumed to have no unit even if it does have a unit. Okay? We just go, okay, it's different for everything. It is pretty much useless to us. It doesn't give us any meaningful information, right? So we just go, we're not going to worry about it. Okay? So you do not need units in KEQ calculations. You do have to, you get 1 mark, or you get a 0.5 marks for writing KEQ. You get 1 mark for writing the KEQ expression. You get 1 mark for plugging everything in. And then you get 1 mark for having your final answer. And then you get 0.5, guess what for? Sig figs. Or something like that, right? Now, when we get further along, you're not going to get that many marks for doing this little work. Do you know what I mean? But I'm trying to build good habits for you right now. Yes? No, you will not lose marks for including units, but your KEQ should not have a unit. Okay? Now, another thing I'd like you to notice, what kind of brackets do we have here? Square brackets. Why do we use square brackets? Because we are saying the concentration of. What kind of brackets do we use when we put the numbers in? Round brackets. Why do we not use square brackets? Because we're not saying the concentration of 2.0s. Does that make sense? Right? Like nobody's measuring the concentration of a 2.0. It's not a particle, so it doesn't have a concentration. It's a number, so you use round brackets. Rond? Round. Now, I can tell you if you use the wrong kind of bracket, I will take off between 0.25 and 0.5 marks, okay? I don't know what AP is going to do. Like, I don't know if they'll be that fussy, but they probably will, because they'll be like, if I see people putting square brackets around numbers in a KEQ expression, that tells me they don't know what square brackets mean. Does that make sense to you? It means you're communicating that you have a lack of knowledge in that area, okay? It is acceptable to leave out units for KEQ and its calculation because the KEQ units don't really mean anything and there's no standard unit. How not to lose marks? Well, we've already talked about all this. You have to write KEQ, you have to write this, square brackets, round brackets around the numbers. Okay, everything we've already talked about. Now, this last one is just weird, but it comes up all the time. These are multiplied. Yes, it's times. So I don't know where this comes from, but I see it frequently, right? People are just writing things down and they put a plus in there. I don't know, it just happens. Just don't do it, okay? Okie dokie? All right. Could you guys try this question? I bet you can solve it. I feel like I've done something wrong. Anyone getting that same answer? No, what have I done wrong? Two point five times 10 to the minus 2, 3.1 times 10 to the minus 3, 8.6 times 10 to the minus 2. What have I done? Oh, I forgot a 0. Was that it? Okay, okay, that's all right. Yeah. Oh, yeah, it should be 0.095. Yes. Yes, yes, yes. I was unable to get over 95% in chemistry 12 because of those things. Oops, I forgot a 0. Oops, I forgot my rounding. Oops. So if you are an oops person, I feel your pain. I know what your pain is like. It's like, no. even in a unit where I felt really good about it, I'd be like, oh well. And not all units did I feel really good about. All right. So So even though there was no unit for given for KEQ, if you're solving for a molarity, you have to write molarity, obviously. Do you think you could, yes. Yes. Yeah? No. You do not need to include units in any KEQ calculation. If you've got a molarity at the end, you need to write molar in your answer, and that's it. Yes. It doesn't matter because there's nothing else down here. So you could if you wanted to, but you don't have to, okay? And in fact, if it weren't so awkward, you don't even need them on the top part. You could do 2.5 times 10 to the minus 2 times 3.1 times 10 to the minus 2, but if you don't use the brackets, it starts to look really ugly, right? So can you guys try the next one? You can show this in 2 steps as well. Okay, I'm just lazy and I like doing it in 1 step, but you can show the finding moles and then dividing by liters. I'll do that for the oxygen. Yes. Yep. You can look at the sig figs at the end. That would be fine. Okay. What you should show is when you should show like these point zeros in your molar masses so you know what sig figs you have in your molar masses. Okay. feel like I've done this wrong. You guys are doing your own work right before you're looking up at mine. Good. Otherwise, we'll never know if I'm wrong or not. I want you to do it so I can tell if I'm wrong, right? Okay. Ah, that's because you rounded your 0.173. Yeah, and I did not. I had that calculation in my calculator, and so I just pressed y to the x4. Right? So you want to use the unrounded value. Okay, or if you don't want to keep the whole thing, you know you have 3 sig figs at the end you want to have, yes? So try using 0.173 with an extra 3. See how that works. Yeah, then you'll get, like, if you don't want to write out like all the 3s, just go one more digit than than you want at the end, and that should solve your sig fig problems, right? Then you don't have to write everything. I'm usually extra cautious and I go 2 more digits than I need, but I don't think it's necessary. Okay. Okay, so we have some exercises there, which we're not going to do. I'll send you home with those. KEQ, what about if we're not yet at equilibrium? Up until now, we've been like, I give you an equilibrium mixture, and here are the equilibrium concentrations. But we've all been about shifting up till this point, yes? And so we're going to take a look at some situations where, for example, I start by putting reactants. SO2 is a reactant, and O2 is a reactant. I start by putting some reactants into my flask. If we have only reactants at the start, which way must we shift? Only reactants at the start. Which way do we shift? We shift to the right, obviously. And what if we have only products at the start? We shift left. And what do we know about the amount of shift, the amount of change in concentration? Change in concentration is like Y in this case is O2 that much, but SO2 is that much. and SO3 is that much. Yes. Yeah, because there is 2 SO2 and 2 SO3 for every 1, which isn't written, O2. Yes? So we make 1 O2 for every 2 SO2s, and in making 2 SO2s, we use up 2 SO3s. Yes? So we're going to use those coefficients in some math. So you have to remember the shifts are proportional to the coefficients. Okay, so here we go. Initially, ooh, look, there's a key word. Initially, this tells you you're not yet at equilibrium. Yes? 2 moles of NaCl was placed in a 1 liter flask. I don't even need to put that word initially in there to let you know that we are not at equilibrium. If I place only NO2 into my flask, am I at equilibrium? No. Or sorry, not NO2, NOCl. So if we place it in a flask and we leave it to reach equilibrium, we're going to have some shifting involved. When the equilibrium is established, it is found that we have 0.66 moles of NO. So that is at equilibrium. And now we need to calculate the KEQ. So the tool we are going to use is going to use the initial concentrations. It's going to use the shift, which is a change in concentration, and then it's going to use the equilibrium concentrations, and at the top of this little table we are going to write the reaction so that we can see the coefficients. Yes? Okay. What are we going to fill in? And I'll just draw some lines here so you can see. You don't have to use lines in a table like this if you don't want to, but you can if you do want to. What is our initial concentration of NOCl? 2 molar, 2.00 molar. What is our initial concentration of NO and Cl? 0. So if you're told that you put something in a flask and you don't put anything else in a flask, then you know the concentration of that one thing and you know the concentration of the other things are 0. So you know all your initial concentrations. Is there another concentration we can fill in on this table? Tell your partner. Is there another concentration we can fill in on this table? What else can we fill in? We know that we have 0.066 moles of NO at equilibrium, yes. And therefore, at equilibrium, we can fill in, and that is in what volume? It's in a 1 liter flask. So our calculation is nice and easy. So that's going to be 0.66 molar. Now, it's just like a little puzzle. If you know two things in a column, you can figure out the third thing in the column. So what's going to go in this box here? Is it going up or down? It's going up, so we're going to put a plus sign. So 0 plus what gives 0.66? It is 0.66. Now I'd like you to put in the signs for the other two changes. NOCl, is that going up or down? It's going down, so we're going to put a negative sign. And the Cl2, is that going up or down? Cl2 is going up because it's being produced. And what quantities will we put in there? Tell your partner. So if we've made 0.66 NO, how much NOCl have we used up? If we've made 0.66 NO, how much NOCl have we used up? 0.66, because they are 2 to 2, which means they are 1 to 1. Now, chlorine has a coefficient of 1, so how much is it going to go up by? You guys should all be like desperately answering me. You should be like, Miss Spence, how are you so stupid that you don't know that it is? Thank you for 3 people who answered me. 0.33. Why is it 0.33? Because it's half, because we have a 1 to 2 ratio. Okay, great. And now we just add or subtract down the column. So 0 plus 0.33 is 0.33. And 2 minus 0.66 is what, 1.34? Did I do that right? Yay, okay. And now, guess what? You have equilibrium concentrations. Do you know how to find a KEQ if you have equilibrium concentrations? Yes, you do, so do it. Off we go. Okay, you know what? There's just a lot of scaffolding here that we don't need. Oh my God. I really need to get rid of all this scaffolding. Skip ahead to page 90. No. No. You know what we're gonna do? We're just gonna do the KEQ at the bottom of the page here. I don't know what is wrong with me. KEQ is equal to, and we go back to our reaction, NOCl2 Okay. Did you get what I got? Did you write KEQ equals? Did you write your square bracket expression? Did you write round brackets around your numbers? And did you have 2 sig figs in your final answer? Good. Now, did I do my math right? That's always a big question. Yeah? Cool. Okay, I'm going to put a big note here that I need to get rid of all this scaffolding. Because these are useless pieces of paper. Okay, so we were on 96. 97 is useless. So is 98. Okay, so 99. Two moles of N2 and 2 moles of O2 are placed in a 2-liter flask and allowed to come to equilibrium. Now, you need to be able to tell whether this is an already at equilibrium or whether it is a I will come to equilibrium and I will use a rice table. Take a look at that question. Tell your partner, how can you tell if you are already at equilibrium or that we are not at equilibrium and we will need to do a shifting rice table? How can you tell? So if you have only reactants and you have allowed to come to equilibrium, you know you're not yet at equilibrium. So do you think you guys can try this one? Yes? Go for it. Yes. Oh, someone would have done a previous experiment where it was at equilibrium and would have calculated it from there. Yeah. Let me know if you get stuck at the change. You got stuck? What did we do back here when we didn't know how much the change was? That's going to be our unknown. Because this time KEQ is not unknown. The amount we're shifting will be the unknown. So you'll change by x or 2x or 3x or whatever the coefficients say. Yeah? So what it's going to look like then is we're going to say, first of all, we have to be shifting to the right because we have no products yet, which means that the products are going up and the reactants are going down. And we have a coefficient of 2, 1, 1. So what are we going to put in each of those blanks there? X, X, and 2x. I kind of like the lines on my table. I don't know. You can put them in or not as you like. What's wrong with me? Do you like what I've written? Yep, we need to have brackets here because otherwise we're not squaring the whole thing. We got to square the whole thing. And you know what's really nice? You could expand everything and end up with a quadratic equation, couldn't you? But who can see an easier way of solving this problem? Oh, I got one. Anyone else see an easier way of solving this problem rather than doing it with a couple other people? Chat with your neighbors, see if you can see an easier way of solving this problem. We don't want to do a quadratic, that's ugly. Everything on the right-hand side is squared. So we can just do that. Yes, we can take the square root of everything. I'm going to write this out, but you can just do the square root here. You can take the square root of 4.51 times 10 to the minus 3 equals 2x over 1.00 minus x. I probably wouldn't bother writing this step. I'd probably just write what the value is for the square root, but I just wanted to show you where the work is coming from. And now you do some algebra. Do the algebra. I don't believe you guys are any good at algebra anymore because they don't bother teaching it they don't focus on it as much anymore. So I'm going to make you do the algebra. Don't watch me do the algebra. You do it and then I'll put mine up. Okay? Back when I was in high school, grade 11 math was called Algebra 11 and grade 12 math was called Algebra 12. And I mean, we did trigonometry and we did a whole bunch of other things, but it was actually called, like the focus was algebra. Yes. Of course. Yeah. What did the question ask for? I'm like, oh, I got next. Woohoo! Oh, I guess I better go back and see what it asked me for. It asked me for the equilibrium NO. And if I look at the equilibrium NO, that is 2x. So the concentration of NO at equilibrium is 2x. Let me know if I did my math wrong. Isn't this fun? No? But it's like you just throw things in and you get the right answer. You know what I mean? Like you're like, oh, I don't actually have to, I don't have to describe like how something relates to something else, right? I'm like, oh, rice table, KEQ, do some algebra, solve it. I don't know. It always made me happy. Woo! Yeah. Homework exercises for 2.3a, 2.3b, 2.3c. Now, do you need to do every question? No. Do like maybe every second question. Yes. Yeah.